Testing. So we shall start off by doing a quick revision of what you all memorized the last week. Alright, Blossom.
Oh yeah, didn't we have a
Test,
Sarah
testing. What?
Didn't we have a that Sarah answer me?
No, yeah.
Today her birthday, right? So James said he want to sing a song. Come,
No,
let's
I
hear.
never say anything. You're the one.
Huh?
Not me.
But you didn't disagree.
I said no. I said no. You also said no.
Okay, whose birthday? Yeah, what 2 days was that? Blossom, right? And then today is Sarah. Then 2 months later is you and anybody else? You seem to have birthdays this couple of weeks.
What?
What? Anybody else having birthdays?
When?
Huh?
When?
Hers is today. Blossom was 2 days ago, right? That's what she says.
Oh.
Yeah. So anyway, we continue our revision. So last year what we did was I gave you a piece of paper. I mean, you all took a piece of paper, asked you to copy down the important stuff. Now
You too smart already last
yeah, he didn't copy because everything is in his brain. Correct or not, Jay? Yeah. Yeah. So what did we do? We did the element, compound, mixture. We also did the solution, suspension, right? Okay. So I'm just gonna continue our revision on specific topic. Are you okay, Rachel? Actually, are you okay? You're a bit stoned, right? Stoning. So yeah, we're just gonna continue the revision. Separation of mixture. So today we will go through separation, mixture, and also revise a bit of what we did last week. Why don't we just give it a try? Okay, let's choose someone.
Birthday girl.
Birthday girl wasn't here last week, right? So not fair. So we will. I want to know what is the definition of solution. Easy. We start with easy one first. What's the definition of solution? Eye contact. Yes, Jim. He was like, eh.
I don't even know solution.
What solution?
I don't know.
Oh, solution.
That's the one thing I don't know.
Why? Solution equals to very close. No, what plus what give you solution?
Solute and solvent.
Rachel, solute and solvent, very good. Solute plus solvent gives you the solution. No, Rachel,
I sleep today.
Rachel, what is a solute? Rachel, what's a solute? What's a solute? Yeah, very good. Okay, actually, what's a solvent?
Sleep, good night.
What's a solvent, Ashley? Hey, David,
What?
come, what's a solvent?
Solvent.
Yeah.
A liquid.
Yeah, it's a liquid that dissolves the solute. Okay, very good. What's the opposite of a solution?
Suspension.
Oh, that's right. Okay. Then we also went to element compound mixture. Now let's ask well. Okay. Blossom, are you there, Blossom? Are you able to talk into the microphone?
Yes.
Yes.
Okay, good. Can you give us a definition of element? Element.
A substance which cannot be broken down into two or more single substances by chemical means.
Yeah, awesome. That is correct. Next, Sarah, what is a compound? Birthday girl, compound.
Two different elements can be.
Very good. Okay, Jim, I contact yes.
What?
I saw you. Jim, what's the mixture, Jim?
Make sure the substance.
Two or more
Yeah,
different
more different
substances.
Not chemical.
Very good, not chemically combined. Okay, Richard, there are four differences between compound and mixture. Give me one of them. There are four differences. Yeah. You say one first. Mixture, okay. Mixture is physically combined, then the compound is chemically combined. Okay, good. Richard, give me. Oh, okay. Fixed proportion. Which one is fixed proportion, MS? Compound is fixed proportion, MS. Mixture is not fixed proportion. Okay, Richard, sorry, they took two already. Still got two more. What the other two?
go to sleep.
What? Actually, wait, I also try to recall.
Properties.
What?
Yeah,
Oh, yeah, the property thing. What about the property thing? One of it has the property same as the component. The other one, compound, huh? Compound is similar.
Mixture.
Mixture, yeah, mixture have chemical properties similar to the component, right? The other compound don't have. It's totally different. One more.
Separation technique.
What? Sorry?
Separation technique.
Is it? Oh, one is chemical.
One is
Yeah, one is physical. Very good, right? So that was what we tried to memorize. Right? We spent one whole lesson memorizing those. Yeah, yeah. So that's why you see he can remember. Everything is science. Yeah, right. So everyone must remember, okay, we gotta memorize all this. So speaking of mixtures, today we'll be going through mixtures, the separation of mixture, separation technique, okay? So it's going to be a revision class as well. Now, as usual, I will be telling you what you have to memorize, what you definitely need to know, right? You can highlight, I'll give you notes, right? So you can highlight. And then after that, we do some questions because set one most important. I mean, this is one of the most important thing in set one, the separation technique. Now, if you take a look at this flow chart here, there are several ways, several separation techniques. But you don't study every single one of them. Okay, for example, I don't think you studied the reverse osmosis. You studied about reverse osmosis? You did. Some yes, some no. Okay. But these five definitely filtration, evaporation, distillation, chromatography. Okay, this one depends. Right, reverse osmosis depends. So I'm not going to go through reverse osmosis. All right, because if you want to go through this, then we have more definitions to memorize. Like what is osmosis? Anybody know? You did, right? What's osmosis?
Nobody knows.
He said he went through one. What's osmosis?
but I wasn't tested.
You tested. Yeah,
The
so
teacher asked,
yeah, so if you want me to go through this, I must go through what is diffusion, what is osmosis, and all that extra things. Okay. So
Diffusion sucks.
what?
Diffusion sucks.
Yeah, diffusion is something like sucking stuff. So yeah, right. So we shall continue. Correct what? So we shall continue our revision 1, 2, 3, 4, 5. Okay, this is fine. Now, here there are a lot of things to understand. Very few things to memorize. Okay, unlike the first few chapters. All right, so first one, magnetic attraction. So what is magnetic attraction? Now, basically all these are physical methods. That means they are only applicable to mixtures. All right, all these methods cannot be used for compounds. You cannot separate compounds with these methods. Okay. So first one is magnetic attraction. So magnetic attraction obviously is to use magnets or the electromagnetic force to extract something like metals such as iron, cobalt, nickel, steel. So these are magnetic materials, right? So how do we memorize them? We say in primary school we say SpongeBob is not cool, correct? No? I don't know. I mean, I remember this acronym. SpongeBob is not cool. Iron, nickel, cobalt, steel. SINC. So these are magnetic materials. Right? Magnetic materials. Any one of these can be used as an electromagnet or can be used to attract, can be attracted to magnets. So electromagnet basically is you use electricity to pass through a metal and you can, turn it into a temporary magnet. Okay, so very easy. This is very easy. Okay, next, filtration. So filtration is used to separate a mixture of liquid and insoluble solid. So what is the crux or the important thing in understanding separation technique? It is you must know this method. What is it supposed to separate? So this is what I'll be asking. Okay, so if I were you, I would highlight this. So for example, I'll be asking you, okay, filtration, what is it used to separate? You must tell me, oh, mixture, liquid, and insoluble solid. Now, you don't really have to memorize because it's a lot of common sense. For example, you look at this. So we say that, oh, this is the filtration process. So what what does it do? You see, you take a mixture of water and sand, you pour it in. You see the water goes down and then the sand is stuck here. Okay? And this stuff that's left here is called the residue, and the one that passes through, which is the water, is called the filtrate. Simple now.
No.
Yeah.
Very hard.
Simple.
We cannot contain it.
Yeah. Alright, next.
I'm not even listening.
You don't understand?
exactly.
I'm just daydreaming.
But you know how to answer the question. That's good enough. Okay, where's the residue? Stuck in the filter funnel. Where's the filtrate? It's the one that passes through.
Yeah.
Simple. Alright, what is filtration used to separate?
The texture.
No, specifically.
Oh. A mixture of a liquid and insoluble solid.
Yeah, that's right.
I was just looking at you now.
No, you're staring into space. It's a bit funny. They're like, no reaction. What is this? You must do some
I was
exercise.
so tired already.
Yeah, why so tired? Is it because of hot sun? Is it because of hot sun?
I was
Hot sun?
sleeping in the car, man.
Hot sun?
No, cannot have eye contact.
Is it because of hot sun?
No, I was sleeping in the car.
You were sleeping in the car.
Tired.
Then?
Huh?
Yeah, never mind. Okay, never mind. Continue. As long as you are, listening, you can't close your ears, okay? You can close your eyes, but you can't close your ears. As long as I keep talking, the information will go in.
I closed one ear.
Now close, show me.
No, the information going one, but how about other?
It doesn't work.
See, one go
doesn't
in,
go.
the other side cannot come out already. Joe,
What?
information go inside.
Yeah.
Inside lot of the information can go out.
Uh-huh.
Inside where?
Uh-huh. Okay.
Yeah.
So several ways of several examples of filtration, right? You don't really need to know all this, okay? Like coffee, the uncle in the coffee shop, he will uncle or auntie, yeah, teh tarik and whatever. No, this is not teh tarik. This is the coffee filter. Nowadays you have very fancy coffee filter. Yeah, that's right. Coffee filters, right? You see?
Just a filter.
Yeah, this looks like a filter paper. You can actually buy the filter paper at NTUC. Yeah, you can carry out your own filtration.
Who wants to?
The coffee filter paper. Okay, it's just filter paper. Right. Okay, here's an example. Coffee filter C. C is like the, what is it used for? Huh?
It's a thingy.
What is it used for? C.
Baking.
Yeah, baking. We all use this during your FC. Yeah.
No,
No, you don't?
I need
Filter.
two things.
Okay, what is this? Car oil filter, car air filter. I don't know if you've seen this before. Okay, so it's something like an aircon filter. Yeah, right. Aircon. If you do servicing for the car, they have to replace this. If not, you'll be breathing in all the dust and everything. Right? If you don't replace, this is a clean one, this is the old one. Okay, all this filter must remove, clean the filter. Okay, this is the car oil filter. Right? This is the air filter. The engine also need a filter. Everything also need a filter. Not everything, right? A lot of things need filter. Okay, especially for the aircon. If not, it will be too dusty, like within the car. So some people like to change the air filter for vehicles. Why? Sound nice. Yeah, you hear all those boom car, right? This is the thing. Okay, they change this thing, and then all of a sudden it sounds like a sports car, but it may not drive like a sports car. All right, which is why.
One of those like Beatles cars.
Yeah, which is why one of this is like quite expensive, like a few $100, I think. Okay, just to sound like a sports car. Okay, so that's the car air filter, and that's the oil filter.
So can you put that on like a bicycle?
Huh? Put on bicycle? No lah. Bicycle doesn't need air filter. Bicycle doesn't need air filter.
The sound will put it though.
No, it doesn't need air filter. Okay, it's pretty easy. Okay, next, evaporation. What is it used to separate? You see evaporation. You see this? Mixture containing a soluble solid. So this is different from just now. Just now is insoluble solid. All right, but here is evaporation is used to separate a soluble solid. In the long run, yes, if you soak yourself in water for 10,000 years, it will dissolve. Okay, so this is heated gently using a water bath, right, like that. So basically the salt solution, water will evaporate and then you'll be left with the salt. So this is called the evaporation technique. Okay, natural or solar evaporation. So this is how we get our salt. Salt, evaporation. Plant, is it called plant? How we get our salt? Yeah, okay, all this plant. This is how we get the salt. Sea salt farm. It's really pink in color. Huh? No. The place or the organization of the equipment, all this, we call it a plant. This is a plant. Right? So the salt is really pink color. I thought it's not pink. So what do? Basically, they just put the seawater there and then just let the salt, the water evaporate, and you'll be left with the salt particles. Right? All the salt particles are left there. So this is called salt mine, right?
How about pink salt?
I don't know. Why are salt pink? I don't know why this. Why are some salt pink? Oh, this sea salt. Sea salt is like this. There are different colors of salt. Pink Himalayan salt. Okay, I'm not too sure about this. Right? Like, why is it some pink? They're just probably coming from different places. Okay, different locations of it. Right. So this one you need to know. Okay, later we'll take some time to remember this because that's what I'm gonna ask. Right? Evaporation, separate mixture containing a soluble solid. It's pretty easy. Next, okay, so this is the one that's a bit harder. This is distillation. You got full marks for this. That's great. What is distillation? What is it used for? Okay. Distillation, pure liquid from a solution. Right? You want to get a pure liquid from a solution. So here's one. You see, just now evaporation, we want to get a salt from seawater. But in this situation, you want the water from seawater. That means you don't want the salt. All right, you want to get pure water. So how it works is they will boil this part, right, and then the water becomes vapor. The vapor form will be passed through this thing called a condenser, right? It will condense, basically changing from gaseous state to liquid state. And then since it's a liquid state, it will drip down and be collected here. So this is pure water. Right, so another way another thing that this one can be used to separate is alcohol and water. I don't know. I mean, I don't know Himalayan salt.
We don't know about salts, but salts is science, and science is
Yes, but I don't know about.
So therefore, if you know why salt.
I don't know about Himalayan salt.
Then.
Wait, wait. I want to show alcohol. Okay, so alcohol and water is yeah, you can drink alcohol, but are you legally allowed to drink alcohol? No. Right, so alcohol and water, yeah, like that. Okay, alcohol and water, they call miscible, so you can't really separate them unless you use this technique. So if you have alcohol and water, the question is usually which one will come out first?
Alcohol.
Why alcohol?
Lower body.
Lower boiling point. What is the boiling point of alcohol? 78 degrees Celsius, right? So whichever substance that has the lower boiling point will evaporate first. So you evaporate, come here, become liquid, and then come down, right? So now there's a need to put a thermometer here. Now you must know that the bulb must be at the opening. Why? Because you want to measure only the vapor. You don't want to measure the liquid. Some people make the mistake of putting the whole thing inside here. No, we don't want to put the whole thing inside here. You just want the bulb to be at the opening so that you can measure the temperature of the gas, which in this case is the alcohol. I mean, in the alcohol vapor. All right. Another thing to note is, now this is wrong. Your water should go, cold water should go in from the bottom and then come out from the top. Okay, so this is the condenser. So what it does is the vapor will condense become liquid and then drop down here. Now, what's the purpose of the porcelain sheet?
Spread out the heat.
Porcelain.
Hmm?
Ensure smooth boiling.
Yeah, ensure smooth boiling, spread out the heat. Yep, that's fine. Prevent the vigorous boiling, because when there's too much vigorous boiling, some of the sea water, the impure substance, right, might jump inside, might jump into this thing. Then your outcome will not be as pure as what you want it to be. Yeah, yeah. Okay. All right. So desalination is one example. Now Singapore runs desalination plants. It is one way in which we get pure water from Singapore. Okay, one of the ways which we get pure water. What are the other ways in which we get pure water? Reservoir, right? We also buy from Malaysia. Okay, I mean most of the water that we need we buy from Malaysia. So this is a desalination plant. Actually, never seen this before. Fourth desalination plant. Where is it?
No, it's in the, you can see a photo next to it.
No, but what location is it? Sea water, fresh water. It's kind of interesting. Okay, now why do we need this? Because we cannot drink seawater. What's the problem with seawater?
Too salty.
When it's too salty, what happens?
Dehydration.
Yeah, basically water will go
We
out.
will become the producers of water.
Yeah, your water will go out of the cells, right? You drink seawater, water go out of the cell, go into the salty, this is seawater. Where is this? Eh, quite recent, no? Seriously, where is oh, this is near Kallang. See the stadium?
Yeah,
But how did they drain the water?
I'm going to
My red car tomorrow.
What are you doing there?
Tournament.
Tournament? What tournament?
Tennis.
Tennis.
Wow.
Wow.
Don't win.
Yeah, I'm not gonna. I don't even want to play the match. The longest time, yeah, okay, let's go there, lose and don't do that anymore.
Alright, so quite interesting to see this. Do you think the public can go? I think people will go out and fly kite again. Yeah, it will become a kite flying place for people. Okay, so this is where we get some pure water from. Okay, desalination plants. Next one. Internet is slow today. Oh no, what happened? Next. Okay, so when we talk about distillation, we must also talk about fractional distillation. So fractional distillation is where oil refineries will get separate crude oil into petrol, diesel, kerosene. So where can you find our oil refinery? It's in this place called Jurong Island. Okay. Now Singapore is actually famous for the this oil refinery. We depend on oil refinery for a living, so that's why this place, right, is a protected area. It looks like that. It literally looks like that. Right, a lot of petrol, chemical
That's the
stuff.
whole city already.
Yeah, yeah, it is. It is a very big place. Okay. If you ever get to go there, it will look very weird. That place doesn't look like Singapore at all.
The desert.
It's not a desert, but it is like it is like stepping into another country when you go into this island. So where exactly is this island?
Jurong.
Yeah, which Yeah, Singapore map. Singapore.
What Jurong Island for
All right. So where is Jurong Island?
Go check the map.
Let's show you the
Go Google Map.
Yeah, go Google Maps right there next to images.
where
There, go up, go up. Maps.
maps. Jurong Island. Anybody been to Jurong Island before?
No, I know whatever.
I went.
Okay, never mind.
I went during army NS. That's slow today. Right, the whole place is reclaimed. It's actually made out of many islands, multiple islands, but Singapore went to reclaim it because what's going on? Okay, we are here. We are somewhere here now. Amkyo, So Jurong Island is here.
Ang-Mo-Kio.
Then Amkyo. You see, Amkyo is this. We are Serangoon near here lah, somewhere here. Can you see how big it is? The whole thing is Jurong Island.
The whole thing.
Yeah, this whole thing is bigger
Look at the
than.
reef, man.
It's like 4 times the size of Sentosa. Okay,
Nah, it's bigger than that.
satellite picture.
Sentosa is small.
4 times, 4 or 5 times. Stuck. Okay, so Jurong Island is here. I wonder if you can drop, like, go in and take a look. Oh, there. All right, so you can see the whole place. Literally, is just petrochemical stuff. Right,
Can you push the thing up?
Sure. Yeah, it's all it's all silos, chemical production. Okay, you might know some adults working inside there. It's a dangerous place to be because if one part were to catch fire, explode, right? Everything is linked by pipes. Everything is linked by pipes everywhere. And drop. You can.
Can I have a speaker?
Speaker. You have to
Take off.
pass behind. Okay, see, we cannot.
Take off.
There are no photographs here, right? It's a restricted place. Cannot drop. Nobody take picture here.
You want more?
Okay, but I think we can drop near there's a bridge. This is like the causeway from Boon Lay, which is Jurong. You can drop here. Right? Yes, you cannot. Wow, we also cannot.
If you zoom in all the way, maybe you can see it. Zoom in all the way.
Yeah, this is all we see. Jurong Highway. All this is to store the petrochemical. Store. So, right, all the storage. I see so much of this. Some cannot drop. Alright, so anyway, they're all doing I mean not all, but a lot of them are doing fractional distillation. Fractional all these pipes.
You should drop it in the middle of the ocean. See what happens.
Cannot. There isn't a street view. There's no street view. Alright. Maybe you can see. I was thinking maybe you can see from here. But here also nobody have it's near the bird park. Oh yeah, do you know why they put the bird park here?
Where?
Bird park. You see the bird park among all the industrial chemical area.
Because they hate birds. If there's something happen, the bird will die.
Absolutely right. You're so clever, right? It's true. Okay. Yeah, it's true. You see, how can it be the whole place, everything industrial, chemical industrial. You see this whole place, chemical industrial area. Then all of a sudden you got a bird park inside. Right? Because birds are very sensitive to poison in the air, poisonous air. So if you see the birds, like something happened to them, that means there's a leakage or there's some problem with the industrial area over here, right? So you're right, they don't like the birds. Right? They are like some kind of a
alarm.
Yeah, alarm. Right? So that's why the Jurong Bird
Drop the
Park.
thing in the bird park.
Huh? What?
Drop the human in the bird park.
Oh, yeah. Have you been to the Jurong Bird Park?
No.
No? What?
It was boring.
Hey, here we go.
Wait, you can.
Bird Park can. Based on interest. Oh, it's a car park.
So that means you don't need to walk there. You can just take out your computer and then just start. Just think better there. I think you can only drop them.
Yeah. Right, it's Bird Park. California. Yeah, it's a very old place. But that's the reason why they put it there. Okay. Anyway, let's continue. Ayo, look at today's internet is intermittent. Okay, let's continue. So that's a fractional distillation. Continue. Next. Okay, last one is chromatography. So what is this chromatography for? Now, paper chromatography is just one type. It's used to separate colored components in mixtures. Okay, so paper chromatography separate colored components in mixtures. So this is how it looks like. If you were to put a drop of the thing that you want to separate, usually on the line, then you dip the bottom end into liquid or some kind of a solvent. Now the solvent will travel upwards. As it is traveling upwards, it will dissolve the thing that you want to investigate, and you will see patterns. So if you see the pattern matches whatever pattern that you want to check for, it will mean that the component has got the exact same thing inside there, right? Okay, what are some of the uses? Detect colorings in sweets and food, because all sweets, most foods nowadays have coloring, right? Most food.
No, rice does not.
What?
Rice does not.
Ayo, but rice is processed. Processed. Yes, rice is processed. How does normal rice look like?
White.
Wrong.
Yellow.
Yeah. Normal rice is yellow or brown in color. Okay. As a what?
You can do this. Then when you wanna
Color of normal rice.
Then when you wanna eat the different.
So whatever we are eating is called polished rice, right? That means
Who polishes rice?
they polish rice. Why?
Grain by
Because
grain, they just go.
no, they put inside machine, of course. Okay, all these are called polish. Right, this is like normal rice, a bit yellow, but the white color ones, right, is more expensive because it's being processed. They actually polish the thing so that when the rice is being cooked, it looks like, oh, this is so nice, it's white in color. That's just marketing, okay? So anyway, most food nowadays have sweets and most food nowadays have colors, and colors are actually unhealthy. So there are also colorings that are that consist of banned chemicals. So you want to check whether the colors are poisonous, right? You gotta use chromatography. Okay, detecting types of ink used in forge checks. Test for urine blood analysis, detect the level of pesticides on fruits and vegetables. Right, police use it to analyze paint pigments and detecting the use of illegal drugs by athletes and sports competitors. Next. So these are the uses of chromatography. Okay, reverse osmosis, I'm not going to go through. So this one I'm not going to go through.
Okay,
Okay.
we're done.
Are we done?
No questions.
Oh yeah, we're done. All right. So now what I need y'all to do is to memorize.
No question, please.
No. You need to memorize. We're gonna make you memorize this first, all right? For example, right? Distillation, you must tell me what is it used to do? Obtain a pure liquid from a solution. And then what is the evaporation? Separate a mixture containing a soluble solid. There are only 4, I think. Filtration, separate a mixture of liquid and insoluble solid. Magnetic don't need. You don't need to memorize it. Right, magnetic attraction, separate magnetic material from that which is not affected by magnetic force. Okay, we're gonna take 5 minutes just to memorize that, and then later we will ask every single one of you. Start with you.
No.
Start with Jim.
Yeah, start with you.
No, that's not